So what's happening here is that in reality an object is reflecting light in the form, well, it's absorbing the frequency of light except for the one that is reflecting off of it, and it's reflecting in all directions. For simplicity, we'll use a ray model. So we'll just pick one beam of light coming from a couple different places. All right. In reality, we can't draw this because every point on this is sending light rays in all directions. But we'll make it a little bit simple and try to figure out what the image is. So in this case, we're going to pick our point, and we will pick an arbitrary light ray. And in this case, I will pick one that comes here. And due to the law of reflection, if I lay a perpendicular line here, a line that's normal to our reflecting surface, then my reflected beam is going to bounce off at the same angle. But because of our eyeballs and our brains, we perceive a reflected beam on the other side of the mirror. So if I do this here, yeah, I'll draw in all the perpendiculars first. So there's one, and there's one. So I want to estimate an angle that's coming off here at the same, so that my reflected angle is the same as my incident angle. And this one is going to bounce the other direction. So there's my reflected angle, or there's my incident angle. My estimating geometry is not very good. And in this case, my angle comes off to about there. I'm going to redo this one. That should have been a little bit of a smaller angle. So I have these rays intersecting about here. This is the one I erased. So this is telling me that in the mirror I'm going to perceive this spot right here. And what we find out is the same distance away from the mirror when it's a planar mirror. And if I do the same from the bottom of the candle, so if I pick this point here, in this case, my reflected angle is going to be about like that. And if I come here, I'm just taking advantage of the perpendiculars, then my reflected angle will be about like that. If I come here, my reflected angle will be about like that. And I'll see that the bottom of my candle here is here. And if I were to do that with every point of light I would reconstruct the image. So my virtual image looks exactly on a plane mirror. My virtual image is upright. It's the same orientation as the object, and it is the same distance back from the object as the object is away from the mirror. This one's a little bit harder. This one's a little bit trickier. So we've got a girl taking a photograph on a bridge. What is happening? Well, she's standing on a boat in the river, so she is in the middle. She's facing the center of the bridge. And the question is, what does her camera see? We know that she's angled her camera so that she's catching both the sky and the water below. Okay? Consider that this ray is going to reflect off the water, and presume your perpendicular line about there. So my incident ray is coming off here. My water is reasonably smooth. We know that some of the light is reflected and some is diffused. And I'm going to eyeball where the reflected ray goes. Notice that she is reflecting from, her image is going to be the underside of the bridge. So this is the picture that her camera will take, which is including what she, from here she cannot see the underside of the bridge, but because her camera is reflecting from the bottom, her image will show the underside of the bridge. The reflected view shows the underside. Or what your eye would see if it were as far below the surface as it is above. So if she is this far above the surface, then it's as if she were that far under the water looking up at the bridge.